All right, and welcome. All right, so we're going to continue and we'll really start our idea of solving. All right, with this lesson. Now, in the previous lesson, we talked about some rules, some properties of numbers, and then what we're going to do now is try to make some connections between what we have already done in this class with systems of equations and how that relates to solving, all right, analytically or with equations. All right, so basically, when we solve, we are looking for the points of intersection. It's primarily the x-coordinates of the points of intersection without having to do the graphs. All right, but to build your understanding about the framework and what's really happening with solving, we are going to look at our systems of equations. So here's what I would like you to do. We have an opener here, parts A, B, C, and D. And this is a review, so you have to graph a line. Where does it intersect y equals 0? Now, a reminder, y equals 0 is the x-axis right here, so the horizontal line. So what I would like you to do is just pause the video. I would like you to graph, all right, A, B, C, and D here, and then tell me, all right, where do they intersect? What points of intersection do you have? So pause the video, do that real quick. All right, flip it back on, and let's see how you did. All right, so I have my work right here, so let's take a look. All right, so if we look at the first graph here, right, we know this is a line, right? No exponents, no absolute value bars. All right, this is in point slope form, and so we know our starting point is 0, -4. We know our rate of change is 1 over 1. All right, and then you can see the line y equals 0 is the x-axis, and we can see that it intersects, all right, at 4, 0, so that would be our solution. All right, so part B here, we know this is an absolute value equation. Our vertex is 0, -4. Our rate of change is 1 over 1, so you can see that we create our V here. Now notice we get 2 points of intersection when we cross, all right, y equals 0 right here. Once again, we get that first point, -4, 0, and then we get the second point, which is 4, 0 right there. So we get 2 points of intersection. All right, and this was the unit that we wrapped up right before we went on break this year, okay? All right, so hopefully this is starting to come back to you. All right, when we look at part C here, all right, this is a quadratic. It has the highest power of 2 for its exponent. All right, once again, we should know that the vertex is 0, -4 right here. And then we do A, 3A, 5A, 7A, right? So A would be 1, 3A would be 3, and then you can see that we get our 2 points of intersection here. All right, if I just drop my camera a little bit here, then we get -2, 0, and 2, 0. Okay, and then we have our exponential function here. All right, it's been a while since we've graphed exponential because we did not graph exponentials in our systems of equations. So just a quick review here. Remember, this is our k value. That's our floor. All right. Right now, what we said is our y-intercept is always going to be 1 above our floor if a is equal to 1. And then this is our multiplier. So then I'm going to go up 2, then I'm going to go up 4, then I'm going to go up 8, and then 16, and on and on and on. All right. And you can see that we get a point of intersection, which is 2, 0. Now, this, all right, this idea is systems of equations, which, like I said, that was our prior unit before we left for winter break. Now, what we want to do is say, okay, how do I find this point of intersection without doing the entire graph? All right, so let's go ahead and turn the page here and let's look at, all right, the next sheet here. So what's happening, all right, when we find those points of intersection? All right, we are really finding where those two functions are equal. So what we're doing is we're going to take each of those functions and we're going to set them equal to each other, and this is what creates an equation. So if we want to know where these two functions are equal, so y equals x minus 4 and y equals 0. So if they're equal, that means they're going to have the same y value. All right, and we saw that in the graph, right? So if I flip back here, so let's keep that here. Let me find my sheet here, right? They have the same y value here. They have the same y value here and here. All right, they also have the same x value, but that's what we're solving for. We know what is that x value. So notice we get x minus 4 is equal to 0. Now, this is where those properties that we talked about yesterday come into play, right? So we talked about this yesterday. X minus 4 is 0. So where or what value is that, right? So 4 minus 4 is 0, so that means x is equal to 4. Well, notice that is exactly where these two things intersect at x equals 4. All right, so notice we didn't have to graph them to find that point of intersection. All right, so for B here, right, the absolute value of x minus 4 is equal to 0. So same thing. Now we're using those properties from our prior lesson, right? So what minus 4 is 0? 4. So whatever's behind my hand has to be 4, which is the absolute value of x. So the absolute value of x is equal to 4. Now, which numbers have an absolute value of 4 or a distance of 4 from 0? Well, it could be -4 or it could be +4. And then once again, we can see, oh, that's where those two things intersect, right? We can see that. All right, let's go to our quadratic here. All right, x squared minus 4, right? Equals 0. All right, and then once again, we're just using that 0 property of addition, right? What minus 4 is 0? 4, right? So whatever's behind my hand has to be 4. This time, it's x squared. Now, what number squared equals to 4? What number times itself is equal to 4? -2 times -2 is 4. So there's one answer. 2 times 2 is 4. There's our second answer. All right, and then once again, we come over here, is that is exactly where this graph intersects, right? Our x-axis, which is y equals 0. Okay, all right. So now hopefully you see two things, right? Why did we talk about those properties yesterday, right? Why did we in our previous lesson talk about those 0 properties and those kind of things, right? It's so that we could use those when we're actually solving. All right, we go to this one, right? Where are these two things equal? So 2 to the x minus 4 is equal to 0. So once again, what minus 4 is 0? 4, right? So whatever is behind my hand has to be 4, and that would be 2 to the x, right? All right, so 2 to what power is 4, right? So 2 to the first power, that's 2, right? 2 squared, that is 4, 2 times 2. So that means x is equal to 2. And then once again, you can see that's where it enters. Maybe if I put it in the screen here, you can see that's where our point of intersection is, right? Okay, so now, all right, so let's talk about why an absolute value and a quadratic have two solutions, right? All right, now graphically, when we talk about this, right, we know that both of these, right, if we have a quadratic and we have an absolute value, they both have a turning point. So if we're going to intersect a line, right, so if we have a line come through, we can see that we could get two solutions, all right? Now, analytically, why is that true without a graph, right? And that gets into those properties we talked about yesterday, right? Okay, because when we say absolute value of a number is equal to something, right, to some number, right, we know that we have 0, we could go that distance to the right, we could go that same distance to the left. So whatever that number is, right, we can go in two directions. That's why we have two solutions. So when we say x squared is equal to a number, right, how do we get two solutions, right? That's because we can do a positive times a positive to get a number, right? But we could also do a negative times a negative to get that number, right? So for example, right, 3 times 3 is 9, right? -3 times -3 is also 9. So analytically, there's two numbers that we can get to 9, 3 times 3, -3 times -3, all right? And so that is why we get two possible solutions. Okay, so now let's take a look and let's just keep exploring this a little bit more, all right? All right, so now, once again, I want you to, all right, pause the video, all right, okay, and try, right, these four graphs. So do E, F, G, and H, and tell me where they intersect, all right? So pause the video, sketch those four graphs real quick. So E, F, G, and H there, just like we did before, and see what happens. All right, so let me grab my sheet here. All right, here we go. All right, so once again, here's our line. Y equals 0 is the x-axis right down here. All right, start at 0, 4. All right, 1 over 1. All right, and then notice I have to kind of go in reverse here to find where it intersects 0, which is at -4, 0. Now look at F here. Our starting point here is 0, 4, and it opens up. And so notice it does not intersect y equals 0 down here. So we don't have a solution, right? We talked about that with our systems, right? We know that it's possible that two things don't intersect, right? It's possible not to have a solution. When we look at G, same thing happens here, right? Our vertex is 0, 4. We go up 1, we go up 3, all right? Y equals 0, once again, is down here, right? So we can see that we don't have any solutions, right? No solutions, no point of intersection, all right? H, all right, now our floor is at +4, right? My A value, or excuse me, my y-intercept is 1 above, and then I go up 2, I go up 4, I go up 8, and then once again, we can see that that exponential is above y equals 0. And we can see that in all three of these, right, there is no solution, all right, which once again, from our lesson, or our unit on systems of equation, we know is a possibility. Now, let's talk about, all right, equation-wise, why does this happen? All right, so once again, if we set these equal to each other, right, x plus 4 is equal to 0. We can use that 0 property. So what plus 4 is 0? Negative 4. So whatever's behind my hand is negative 4, and that would be x. All right, and x equals negative 4. That makes sense. We can have that. That's why we had that point of intersection. But notice what happens when we do this one. The absolute value of x plus 4 is equal to 0. So once again, I can use my 0 property. What plus 4 is 0? Negative 4. Whatever's behind my hand has to be negative 4. And that's the absolute value of x. All right, so the absolute value of x is negative 4. Now, remember what we talked about with our properties, right? We know an absolute value can't be negative because it's a distance, right? And so this is why we have no solution, all right, analytically or with an equation, right? Okay, so graphically, we didn't see any points of intersection, right? Analytically, all right, with our equations, we know this doesn't make sense because an absolute value always has to be positive because it's a distance. All right, now, let's look at what happens when we do this one. X squared plus 4 is equal to 0. All right, what plus 4 is 0? Negative 4. So whatever's behind my hand has to be negative 4, and that would be x squared. All right, and we talked about this with our properties, right? A quadratic can't equal to a negative, right? Because if we're multiplying the same number, we're either going to get a positive times a positive or a negative times a negative times a negative. And in either case, it has to be a positive result at the end. The only way we can get a negative number when we multiply is if we have one sign of each, which can't be a perfect square, right? So this can't happen. So that's the reason why this would be a no solution. All right, keep going. All right. All right, now once again, what plus 4 is 0? Negative 4. So 2 to the x is equal to negative 4. Once again, an exponential can't be negative. Why, right? Well, what are we multiplying? We're always multiplying positive 2's, right? This is what this is, 2 to the x, right? I'm multiplying 1 2 or 2 2's or 3 2's or 8 2's or 9 2's. But it doesn't matter how many 2's I'm multiplying because those 2's will always be positive. And if I'm always multiplying positive numbers, then my result has to be positive. It can never be negative. And so that's why it's no solution. All right. So even though the reason, right, is slightly different for the quadratic, the exponential, and the absolute value, right, the idea is none of the three can ever equal to a negative number. Different reasons, all right, but the same result, right? No solution whenever that happens. All right. Okay, so I've kind of covered all of this already, right? So we saw graphically, right, that we can just have a graph and no points of intersection, right? So we could have something like this, right? And then analytically, I just went through the reasoning for those three guys right there. All right, we have one more set of graph to go through. This is a little bit of a longer video. All right, so flip to the next page and you have four more graphs here. All right, so these shouldn't take you too long. So sketch those, all right, see where they intersect, flip that video back on, and we'll go through these. All right, so let's see how you did. All right, so when I look at this guy, right? All right, start at 0, 0, slope of 1, and we can see that my point of intersection is 0, 0. All right, vertex is at 0, 0. Go up 1 over 1, right, in both directions, y equals 0. I can see that my point of intersection is 0, 0. All right, same thing with our quadratic here. Our vertex is 0, 0. Go up a, go up 3a. Our point of intersection is still 0, 0. Now notice on this, right, exponential, 2 to the x, our floor is 0. Our floor is 0. And then we go up 1, up 2, up 4. And so notice we don't get a point of intersection here, and we'll talk about why in just a second. So we can see that that is a no solution problem. All right, so let's just go through the algebra real quick, all right, and make sure that we're good. All right, so once again, we want to set these two things equal. So x is equal to 0. Well, where is x equal to 0? Its only choice is 0, right? Okay, that should make sense. One solution. The absolute value of x is equal to 0. Well, which numbers have a distance of 0 from 0? Just 0. That's why there's only one solution. All right, x squared equals 0. All right, well, what number times itself is 0? Well, there's only one number times itself that would be 0, and that would also be 0. All right, 2 to the x is equal to 0. Now, once again, right, if I'm always multiplying by 2, I can't get to 0 because I'd have to have 2 times 0 somewhere, right? But if I'm only multiplying 2's, I can never get to 0, and that is why it is no solution. All right, so that's where we're going to wrap up this video. And what we're going to do, all right, when we get back to class is that we will take this, all right, and we'll just continue working on our solving process. So thank you for being patient with this first lesson, all right, and I'll see you in class.